You press play on this video because something in the title spoke to you. Maybe it was the idea that an object from another star just swept past Mars. Maybe it was the hint that something unexpected followed. Or maybe it was simply the promise of a quiet story, something that helps you unwind after another long day. Whatever the reason, you're here now, and that alone places you inside a moment most people on Earth missed. Because only a few weeks ago, in the calm of early October, something rare happened in the night above Mars. And only in the last few days, at the end of November, enough new data finally came in for us to understand what truly unfolded. You clicked tonight because you wanted to be part of a story that's both real and peaceful. A story that isn't trying to scare you or overwhelm you, but gently expand the edges of your world. Something that lets you learn while letting your shoulders drop a little. And this story begins with a traveler older than Earth, moving faster than anything bound to the sun, drifting through our solar system on a path it will never take again. You've heard of comets before, but this isn't one of them. Not in the usual sense. This one came from another star system entirely, the third interstellar visitor in human history. Most people never knew it passed by. They were busy, distracted, locked in routines and headlines. But you clicked on this video because some part of you still looks up. Some part of you wants to understand the quiet events that make the universe feel bigger than your day, bigger than your worries, bigger than anything you carried into this evening. The truth is simple. On October 3rd, Atlas passed near Mars, and something unexpected happened. Not dangerous, not dramatic, but meaningful. Something that changed the way astronomers think about objects from other stars, and more importantly, something that gives you a moment of perspective tonight. Picture Mars for a moment. A cold world with deserts older than any on Earth. A place where wind whispers through ancient valleys and thin clouds drift over forgotten lakes. Orbiters circle above it like patient guardians. MRO with its sharp eyes, MAVEN with its atmospheric sensors, TGO and Mars Express listening for every trace of gas and dust. For years, these spacecraft have studied the red planet, not the sky around it. But on that night, they looked outward, away from Mars, towards something moving across the darkness. You clicked because you want to know what they saw. Atlas wasn't supposed to do anything unusual. It was expected to glow, to shed a tail, to move along its path and fade. But when Mars looked up, the spacecraft recorded patterns in the tail that didn't match the models. They captured a hydrogen cloud larger than expected. So large, in fact, that MAVEN had to widen its analysis window. They measured a subtle shift in trajectory that Earth-based telescopes couldn't detect on their own. And when all the scattered observations were combined in late November, a new picture began to form. It wasn't a picture of danger. It wasn't a picture of alien technology. It was something more subtle and somehow more intriguing. You're here because you want to understand that picture, but you also want a moment to breathe. So take this slowly. Imagine yourself outside under a dark winter sky. The air is crisp. The world around you is quiet. And above you, in the deep cold where sunlight stretches thin, a visitor from another star glides past the orbit of Mars. It won't return. It won't loop back. It won't become part of the solar system's family. It will drift on, carrying the chemistry of a world you will never see. And yet, for one night, it came close enough for Mars to notice. There's something comforting about that idea, something grounding. In your life, you may be surrounded by noise, responsibilities, expectations, deadlines, the steady pull of everything you have to manage. But stories like this remind you that not everything demands your attention. Some things simply happen, quietly, beautifully, without asking anything from you except a moment of curiosity. You clicked because the title whispered that something unexpected occurred, and you want to know what it was. But deeper than that, you want to feel part of the universe again, part of something that isn't a task or an obligation, something that simply is, something vast enough to shrink the weight you carry. So here's the promise for tonight. You will hear what happened when Atlas swept past Mars. You will hear what the orbiters detected and why scientists are still piecing together the meaning of those signals. You will hear what makes Atlas different from the comets you grew up learning about, and you will hear why this single, quiet pass reveals more about interstellar objects than anything since Oumuamua. But before we explore all of that, settle in for just a moment longer. Let your breathing slow. Let your shoulders release. You're not here to race through information. You're here to drift with it, to follow it the way Atlas followed its long path into the sun's neighborhood. Tonight, you're allowed to be curious in a calm way. You're allowed to step back from the noise and let something immense and ancient carry you for a while. This is the night Mars got a visitor, and this is where your part in the story begins. You stay with the story, and now it shifts into the kind of update you secretly hoped for when you clicked. Not rumors, not recycled talking points from October. This is the kind of quiet briefing you would get if you walked into a room at NASA or ESA this week, late in the evening, while tired scientists poured one last coffee and pulled up the latest plots. Everything you're about to hear is where things actually stand as of early December, after the delays, after the shutdown, after the data finally made it through. To understand why this moment is special, you need a clean timeline. Think of it like a simple spine running through the story. It begins on July 1st, 2025, when the Atlas survey in Chile noticed a faint dot sliding across the sky. At first, it looked like just another distant object. But night after night, the motion refused to match the usual curves of asteroids and comets bound to the sun. When astronomers fit its path, they didn't get an ellipse, they got a hyperbola. That one shape told them almost everything. This thing wasn't looping back. It wasn't part of the family. It was passing through. That's when it earned its name, 3I Atlas, the third confirmed interstellar visitor in all of human history. From that moment, every observation counted. These objects are one-time opportunities. There's no second orbit, no next pass. If you miss them, they're gone for good. You could live an entire lifetime and never see another one cross this close again. That's why, as soon as Atlas was flagged as interstellar, telescopes and spacecraft quietly began tracking it, frame by frame, night after night. The next anchor point in the timeline is October 3rd. On that date, Atlas passed near Mars. Near, in astronomical terms, still tens of millions of miles away, but close enough that Mars had a better angle on it than Earth. For a brief window, the red planet became more than a dusty world we study. It became a second observatory, a second vantage point in space, turning the whole solar system into a stereo camera aimed at a single, fast-moving target. Then came October 29th, when Atlas reached perihelion, its closest approach to the Sun. There, bathed in intense light and heat, it woke up fully. It shed more dust. It released more gas. Its tails stretched and twisted, reshaped by sunlight and the solar wind. From Earth, it looked like one more dramatic but distant display. From Mars, it was geometry we'd never had before. Now here's where the story takes on that quiet, human layer you rarely hear about. Just as the spacecraft were feeding home their data, a government shutdown on Earth slowed everything down. The orbiters didn't stop working. The sensors didn't turn off. But the people who receive, process, and publish that information were scattered, delayed, forced to wait. So the images and graphs from October sat in digital queues while the world moved on to other headlines. That's why the timing of this video matters so much. Only in the second half of November did the backlog finally clear. Only then did the teams finish processing the HiRISE images, the TGO measurements, the MAVEN hydrogen plots. Only then did they sit down, compare notes, and update the models. And only now, in the first days of December, is the story solid enough to tell properly. You're not late to this. You're catching it just as the fog is lifting. So what is 3i Atlas, as we understand it tonight? You don't need every number. You just need a felt sense of scale. The nucleus appears to be several miles across, larger than the strange sliver of Oumuamua, and more in line with a hefty, active comet. Its speed is extreme, racing through the inner solar system at over 100,000 miles per hour, a bullet of ice and dust from another sun. Around that solid core, solar heat has drawn out a wide glowing coma, multiple tails of dust and ionized gas, and an even larger, invisible envelope of hydrogen, atoms stripped from water molecules, fanned out into a vast, thin cloud. From Earth alone, you could already tell it was energetic, bright, busy. But Earth's view is just one line of sight. What changed after the Mars flyby is how clearly we can now trace its path and behavior in 3 dimensions. This is where the new data shines. Using the slightly different angle from Mars, scientists were able to sharpen the orbit of Atlas by almost an order of magnitude. Imagine starting with a broad band of possibilities on a map, a thick stroke showing where you think the object might go. Now imagine tightening that into a thin, clean line. That's what the Mars geometry did. It turned guesswork into precision. For an interstellar visitor, that's not just a nice detail, that's history. The next time someone studies the distribution of interstellar objects passing through the Sun's neighborhood, your moment in time, the one you're listening to now, will be one of their reference points. Then there are the images themselves. HiRISE, the high-resolution camera aboard Mars Reconnaissance Orbiter, did something it wasn't originally built for. Instead of staring down at canyons and dunes, it looked outward, toward the moving smudge of Atlas. The resulting pictures are faint and subtle, but in them, you can see differences in the brightness and structure of the tail over time. Small asymmetries that don't quite match the simplest textbook models of how comets should behave. Those images were processed and released only in late November. Before that, they were just raw data sitting on drives. Meanwhile, MAVEN, which usually studies the upper atmosphere of Mars, caught the hydrogen cloud around Atlas in ultraviolet light. The size and shape of that cloud turned out to be larger and more diffuse than early estimates suggested. The graph isn't something you'll see on the evening news, but it's the kind of plot that quietly changes how scientists talk about outgassing in interstellar comets. And that graph, too, only became publicly available at the end of November, after the shutdown delays were resolved. As you listen, notice how all of this feels. You aren't hearing a stale recap. You're being walked through the latest understanding, almost in real time, the way insiders brief each other, calmly, clearly, no rush, no hype, just the satisfaction of watching a fuzzy story come into focus. And that's the real shift. 3I Atlas isn't a mysterious dot anymore. It isn't just a name on a list. It's becoming a detailed case study, a moving laboratory for how ice, dust, gas, and gravity behave when they're born under a different star. The more the data settles, the more you can feel its personality emerging. Restless, active, complex. One scientist summarized it this way: when you study an interstellar object, you're studying the history of another sun. Tonight, that history is not abstract. It has a date stamp. It has a path. It has a moment when it swept past Mars and let us see it from more than one world at once. For the first time, we're seeing an interstellar visitor from the vantage point of another planet. And the most interesting part, as you're about to hear, isn't just the comet itself, but what it did to our measurements and to the quiet old world that watched it pass. And the planet that gave us the clearest view was Mars. You move deeper into the story now, and the focus shifts from the visitor to the world that happened to be standing in the right place at the right time. To understand what Mars saw, you first have to understand Mars itself. Not the Mars of headlines or rover selfies, but the Mars that exists in the quiet hours of the universe. The Mars that spins through the dark with no crowds, no noise, no expectations. The Mars that has been waiting, whether it meant to or not. Imagine standing on a high ridge of the red planet just as the sun dips low on the horizon. The desert stretches in every direction, an ocean of rusted stone frozen in place. The wind is thin, barely strong enough to lift dust, but it carries memories of storms that once swept across entire hemispheres. In the distance, canyons carved by ancient rivers lie open like old pages. Every rock, every dune, every shadow sits quietly, exactly where it has been for ages. Mars doesn't rush. Mars doesn't argue with time. Mars simply endures. If you close your eyes, you can picture it clearly because you've seen pieces of it in photos. The reddish sky, the long blue sunsets, the pale sun glowing through the dust. And somewhere in that landscape, you can imagine the robotic explorers going about their work. Perseverance's robotic arm moving with slow precision, like an old craftsman polishing a single stone. Curiosity's wheels pressing soft tracks into soil that hasn't been touched for millions of years. They take their samples, run their tests, send their signals home. Not hurried, not restless, just steady, purposeful. Yet Mars is more than the quiet world you see in images. It's a world with a past. It once held oceans that shimmered under a younger sun, lakes that reflected clouds, and rivers that carved valleys now left dry. Long before Earth had forests or cities, Mars had water flowing over its surface. It had storms, climate, seasons, and probably chemistry that tried, at least once, to shape something living. That world is gone now, but the traces remain. It's why one scientist called Mars a museum of lost oceans. The phrase fits. When you picture Mars today, you're looking at what happens when a world grows older, colder, and quieter. Orbiting above this ancient world is a patient fleet of watchers. Mars Reconnaissance Orbiter, with its sharp HiRISE camera, normally spends its days mapping canyons, dunes, and rover paths. MAVEN circles high above, measuring the upper atmosphere and the slow leak of air into space. The Trace Gas Orbiter studies faint gases, searching for clues about the planet's chemistry. Mars Express scans the surface and atmosphere from yet another angle, sending stereo images back to Earth. Together, these spacecraft create a kind of quiet traffic above a world that no longer expects surprises. And that is what makes this moment unusual. Mars, in many ways, feels familiar to you. It's steady, predictable, a world that just does its job every day without asking much in return. If Mars were a person, it would feel like an older man who has lived through storms and found peace in routine. A man who wakes, works, rests, and doesn't expect anyone to drop by without notice. Mars doesn't look for drama. It doesn't wait for company. It feels content in its solitude. In that way, Mars is more like you than you might realize. You've gone through storms in your own life, difficult years, long nights, quiet victories, and days that felt heavier than they should have. Maybe you're at a phase where you want more calm than chaos, more quiet mornings, fewer surprises. Maybe that's why stories like this comfort you. They don't demand anything. They just sit beside you like an old friend and tell you something interesting. But even for worlds, and for people who don't expect visitors, life still has a way of surprising them. So imagine Mars on the night Atlas passed near it. The spacecraft above the planet weren't designed to watch interstellar comets, but on that night, they turned their instruments away from the surface and toward the dark sky. And Mars itself, spinning slowly under those spacecraft, became part of the observation. The same planet that once carried oceans and storms now played host to something rare. A moment when a world witnessed a traveler from another star system drift across its sky. This wasn't a moment anyone predicted when the rovers were launched or when the orbiters began their missions. It wasn't part of any plan. It simply happened. A streak of light moving across the black. A long, thin glow reflecting sunlight from a place far beyond the sun. A quiet visitor passing within view of a world that didn't expect company. There's a kind of beauty in that. A kind of cosmic déjà vu. You may have felt it yourself at times. An unexpected moment. A surprise that isn't loud or dramatic, but lands softly and stays with you. Mars had one of those moments. A moment when something from the deep dark brushed past its sky and turned it, briefly, into the second set of eyes for all humanity. As you picture it, you can sense why this matters. Mars isn't just a backdrop in this story. It isn't just a point in space. It's a character, a quiet one, but an essential one. Without Mars, without its orbiters, without its geometry in early October, the story of Atlas would be far less complete. Mars didn't just happen to be there. Mars helped us see. Mars helped us understand. Mars played a part that no other world could. And that's the subtle power of this moment. You start to feel connected, Not just to the comet, not just to the science, but to Mars itself. A world that's been through more than we can imagine. A world once full of water and storms, now quiet and cold. A world that on one unplanned night lifted its face toward the sky and noticed a visitor sliding past. Mars didn't expect a visitor, but that's often how life works. The things that matter most arrive quietly, on nights when the world feels ordinary, and they change the story without ever raising their voice. Mars has something to show us, something no other world could. And from this quiet world came the clearest look at the unexpected. You've come this far. And now the story reaches the night when everything aligned in a way no simulation, no long-term mission plan, and no scientist could have predicted. You already understand Mars as a quiet, weathered world, turning steadily through the dark. You understand Atlas as a restless traveler from another star, drifting through our solar system with a kind of ancient momentum. Now, you get to witness the moment their paths crossed, not closely enough to threaten anything, but close enough to rewrite what we know. Picture the date, October 3rd, a night like any other on Mars. The thin wind moved across the plains. Perseverance and curiosity went about their routines. The orbiters circled the planet the way they always do. Calm, reliable, predictable. Nothing on the surface or in the sky hinted that this night would be different. Yet far above the horizon, in the dark, beyond Mars's wisps of atmosphere, a faint glow was sliding into view. That glow was 3i Atlas, at a distance of about 29 to 30 million kilometers. Not close in the way you think of close, but in cosmic terms, close enough for Mars to become a perfect observation point. Mars wasn't in danger. There was never any risk of impact. But for the first time in human history, a world other than Earth was in the right place at the right time to photograph a visitor from another star. It's something no mission designer had planned. It's something no scientist expected. But it happened anyway, and the orbiters reacted exactly the way they were built to, quietly, efficiently, without hesitation. Mars Reconnaissance Orbiter, with its HiRISE camera, is one of the sharpest eyes humanity has placed anywhere in space. Normally, it gazes downward, capturing the details of dunes, ravines, cliffs, and rover tracks. But on that night, HiRISE pointed upward instead, away from the surface, toward the dark sky. It captured the coma of Atlas, a faint cloud of dust and gas glowing around the nucleus. It recorded subtle structure in the jets that streamed away from the object. And over several exposures, it caught changes in brightness that revealed how the jets shifted as Atlas rotated. These images were too faint to appreciate immediately. Only after weeks of processing, and only after the end of November data release, did the full picture emerge. While HiRISE watched in visible light, MAVEN scanned in ultraviolet. MAVEN isn't a comet observatory. It's designed to study the upper atmosphere of Mars, but its instruments are sensitive to hydrogen as it fluoresces under sunlight. That made MAVEN unexpectedly perfect for capturing the hydrogen corona around Atlas. And what it saw was larger than expected. A huge, invisible cloud reaching far beyond the comet's bright core. MAVEN's readings added something Earth-based telescopes couldn't. A deeper sense of scale, These ultraviolet maps were just released at the end of November, delayed by the shutdown, and they show a comet shedding more hydrogen than early predictions ever suggested. Meanwhile, the Trace Gas Orbiter collected its own set of clues. It measured the polarization of light scattered by dust around Atlas. That may sound abstract, but polarization reveals the size and composition of the particles. It's like looking at dust grains through a special filter, seeing how they twist light. Mars Express added another layer by measuring how the tail shifted as Atlas moved across the sky. Together, these spacecraft didn't just take pictures. They captured the comet from multiple wavelengths, multiple angles, multiple instruments, all working in quiet synchrony. And this is where the first unexpected layer appears. Astronomers expected Atlas to behave like a simple comet with a single dominant tail pointing away from the sun. Instead, the data from Mars showed multiple jets spraying in different directions, creating a network of structures that didn't match the simple one tail, one direction model. These jets flickered, brightened, and faded as the comet tumbled. It wasn't smooth. It wasn't symmetrical. It behaved more like a restless machine than a tidy snowball of ice. From Earth, these details were blurred by distance. From Mars, they were unmistakable. Then came the second unexpected layer, maybe the most important of all. When the measurements from Mars were folded into the orbital calculations, the trajectory of Atlas tightened dramatically. What had been a wide band of uncertainty became a sharp, narrow line. The orbit became 10 times more precise. That precision revealed something subtle. The comet was experiencing non-gravitational forces stronger than originally assumed. The jets weren't just pretty features. They were pushing the comet, nudging its path, altering its motion in ways Earth couldn't measure alone. For a moment, imagine that. An interstellar visitor passing through the solar system, its path being reshaped by the very material it sheds, and a planet tens of millions of miles away helping us measure it. Nothing like this has happened before. No other interstellar object has been photographed or analyzed from another world. We didn't design the Mars missions for this. We didn't prepare for it. We didn't even expect it. But Mars gave us an angle. Earth never could. The data released toward the end of November made this clear. The images from HiRISE, the hydrogen maps from MAVEN, the polarization measurements from TGO, the stereo views from Mars Express, all delayed, then released in a burst, like a story finally clearing its throat. And once it did, Atlas transformed from a distant curiosity into a three-dimensional reality. Something active, something evolving, something far more complex than the simple comet model you learned about in school. As you listen, notice how the feeling shifts. The tone gets a little quicker. The details feel sharper. The story feels like it's building towards something. This is the moment when the calm wonder you've been drifting in begins to pick up a gentle momentum. Not frantic, not tense, just enough to let you know you're approaching something important. And then comes the realization. This was the setup, the flyby of Mars, the unexpected clarity, the multiple jets, the refined orbit, the hydrogen cloud. All these pieces are lining up to show you what comes next. The part scientists didn't predict. The part that makes Atlas different from other comets. The the part that makes this entire event matter more than anyone assumed in July. You probably didn't expect to hear a sentence like this in your lifetime, but it's true. We photographed an interstellar visitor from another world. And that simple fact is enough to reshape the rest of the story. Mars gave us an angle Earth never could. And here is where the story turns. Because what we saw next was not what anyone predicted. By the time you reach this part of the story, you're already settled into the rhythm of Atlas's strange journey. You've pictured Mars as a quiet observer, seen how the orbiters turned their eyes upward, and felt the significance of capturing an interstellar visitor from another world. Now comes the moment when the pieces begin to rearrange themselves. When the story shifts from what we expected to what actually happened. And the truth is, nothing about 3i Atlas behaved the way a simple comet is supposed to behave. Think back to the picture painted in the previous section. Through October and November, scientists combined data from Mars with data from Earth, from space telescopes, from deep sky surveys. For weeks, the fragments didn't seem unusual on their own. A jet here, a flare there, a faint glow, a shift in brightness. But toward the end of November, after the shutdown delays lifted and the backlog finally cleared, researchers began stitching every angle, every exposure, every spectrum into a cohesive picture. And what emerged wasn't the calm, predictable shape of a standard comet. It was something livelier, something wilder, something far more dynamic than any model had prepared us for. To understand the surprise, it helps to remember what a simple comet is supposed to be. The kind you read about in textbooks. The kind you might explain to a child. A comet, in its most basic form, is a frozen mix of ice and rock. A nucleus that begins to hiss with energy when it approaches the sun. As sunlight warms it, pockets of volatile ice begin to sublimate, releasing gas and dust through one or two primary jets. These jets help form the classic picture we all know. A dust tail that curves gently along the comet's path, and an ion tail that stretches straight away from the sun. For decades, this model has worked well enough. It's simple, it's intuitive, and most comets behave accordingly. But Atlas didn't. When scientists overlaid the Mars-based measurements with the Earth-based ones, they realized the object wasn't following the script. The coma, its glowing atmosphere, was not uniform. The jets were not limited to one or two steady plumes. Instead, Atlas produced a pattern of multiple small jets spraying from different points on its nucleus. Some were strong, some were faint, some flared and faded, and many of them weren't aligned with the expected sun-comet direction. It was as if the comet had too many exhaust ports, each one firing at its own rhythm. Even more surprising, there were hints of an anti-tail, a faint streak of dust that appeared to point in a direction that seemed wrong when compared to the main flow. Anti-tails happen, but they're rare, and when they do appear, they usually require special geometry and precise observation conditions. But here, with Atlas, Mars caught something Earth alone probably would have missed. Brightness, too, was unpredictable. Instead of increasing and decreasing smoothly as the comet rotated, the brightness fluctuated in ways that made the nucleus feel restless, like a machine with uneven gears. The models that describe how a comet sheds material predicted far gentler changes. Atlas simply refused to cooperate. Then came the most surprising piece of all: the non-gravitational acceleration. Every active comet experiences a small push from its own jets, the same way a leaking hose might nudge itself backward on a driveway. But Atlas's push was larger than expected. In fact, when scientists recalculated the orbit using Mars's angle, they had to adjust the constants in their models. It wasn't enough to assume a single uniform jet. The comet's multiple jets were creating a complicated dance of forces, each one nudging the object in a slightly different direction. Explaining this to someone who isn't a scientist can sound intimidating, but the metaphor is simple. Imagine trying to predict the path of a garden hose that's spraying water from several holes at once. Each leak creates a tiny push, and together they make the hose slide unpredictably across the ground. That's what Atlas was doing, shifting, drifting, refusing to move in a smooth, tidy arc. For orbital modelers, this isn't a crisis. It's more like a challenging puzzle. A nightmarish one, perhaps, but an exciting nightmare. The kind that makes you lean closer to the equations instead of leaning away. And for you, listening to this story late at night, it means something far simpler. Atlas is telling us more about itself than a typical comet ever does, because every tail is a clue. The dust tail tells us the size and texture of the particles. The ion tail speaks to the plasma environment and the interaction with the solar wind. The hydrogen corona, mapped beautifully by MAVEN, reveals how much water the comet is losing as it warms. When you combine all of these, 3I Atlas becomes less like a single object and more like a series of messages layered on top of one another. Dust saying one thing, plasma saying another, hydrogen saying something deeper still. It's not one voice, it's a chorus. And if you're a man in your 40s, listening to this in the quiet of your room, maybe that complexity feels familiar. Maybe it reminds you that your own life stopped being simple a long time ago. You don't have one role. You have several. You don't have one source of pressure. You have many. You have your job, your responsibilities, your family, your past, your worries, your hopes, each one pulling you in its direction, each one a kind of jet. Sometimes the forces balance, sometimes they don't. But through it all, you keep moving on your path. Atlas, in its strange way, mirrors that. A simple textbook object behaving in a way that only decades of experience or countless years drifting between stars could explain. It's not neat, it's not symmetrical, but it's real, it's honest. And its complexity is a sign of its age and its journey. You might even find comfort in that, because even a piece of ice and dust from another star system isn't simple. Even a comet, traveling through the dark for millions of years, has layers it didn't show at first glance. Even something as ancient as Atlas can surprise us after all this time. And that's the quiet beauty of the unexpected. It isn't frightening. It's revealing. So ask yourself, just for a moment, if a single interstellar comet can behave this strangely, what does that say about the places it came from? What does it say about the star system that formed it? About the forces that shaped it? About the billions of other objects we haven't seen yet? We're watching a comet from another star constantly refuse to behave like the comets we thought we understood. And the only reason we can trace these tiny, stubborn pushes on its orbit is because Mars was in exactly the right place at exactly the right time. By now, the story has shifted, quietly, steadily, from the comet itself to what it allowed us to learn. Atlas acted like a restless messenger, but Mars became something else entirely. A measuring stick in the dark. A second point of reference in a cosmos where everything usually moves too far and too freely to pin down. And that single fact changes everything. Because once you add a second viewpoint, the universe stops being a flat picture and becomes something three-dimensional. If you've ever tried to judge the distance of something using just one eye, you know how tricky it is. The world flattens. Depth becomes an illusion. You're guessing more than you're measuring. That's what astronomers deal with every day. Observing from Earth alone, no matter how good the telescope, is like looking with one eye closed. You can measure brightness, direction, curvature, speed, but you cannot escape the inherent limits of a single vantage point. The sky hides depth, just as a photograph hides distance. But the moment you add a second observer, everything sharpens. You can triangulate. You can trace a path in true 3D. And if that second observer isn't a satellite near Earth, but an entire planet with its own fleet of spacecraft, the precision increases dramatically. That's what happened with Mars. When Atlas passed near it on October 3rd, the orbiters became accidental contributors to one of the most precise interstellar object measurements in history, not because they were built for it, but because they were simply there, moving through their routines, when a visitor from another star slipped across their sky. Trace Gas Orbiter and Mars Express played the first role. Their vantage points allowed astronomers to compare the position of Atlas against the background stars from a completely different angle than the one Earth had. It's like watching a car move down a highway from two far apart overpasses instead of one. Suddenly, you can see exactly how it shifts relative to the landscape. Then came Mars Reconnaissance Orbiter. HiRISE's images of Atlas were faint, grainy, almost ghost-like. But that didn't matter. What mattered was the timestamp, the geometry, the fact that each exposure pinned down Atlas's position from a fixed location, orbiting another planet. Those measurements, even in their faintness, became anchors. Points in space-time that tightened the entire orbital calculation. MAVEN, too, added more than people expected. Its ultraviolet readings weren't just about hydrogen. They helped determine the comet's position relative to Mars's limb, providing subtle cues about distance and motion. Each instrument contributed a different slice of truth. And when those slices were stacked, aligned, and fed into a single orbital model, something remarkable happened. The path of Atlas sharpened. Imagine holding a pencil and drawing a line with your hand slightly shaking. The line is thick, wobbly, a band rather than a single stroke. That's what Atlas's orbit looked like before the Mars data. Still good, still useful, but broad, soft, uncertain. Now imagine taking the same shaky line and overlaying dozens of straight edges along it. Rulers, guides, angles, constraints. Slowly, the band thins. The wobble shrinks. Eventually, what looked wide as a finger becomes narrow as a hair. That's what Mars allowed us to do. Refining the orbit by a factor of 10 isn't a small achievement. It's the difference between guessing which block a car will drive through and knowing which lane it's in. It's the difference between predicting that a comet will pass somewhere near Earth, and knowing exactly how many millions of miles away it will slide. Precision isn't a luxury here. It's the foundation of understanding, and, one day, of survival. Because this isn't just a story about a comet. It's a story about planetary defense, even if the object in question posed no threat. Every time humanity measures something well, we get stronger. Every time we track something accurately, we learn what's possible. The interstellar visitor was harmless, but the process around it was a rehearsal. A quiet, calm, unannounced fire drill that the solar system handed us. Think of the steps: early discovery, rapid classification, recognition that the object would pass near Mars, redirecting instruments already in orbit, combining every measurement into a refined orbital solution, sharing the results globally, all without panic, all without drama, all without waking most people on Earth. In a way, it's exactly what you do around this age. When you begin to take long-term risk seriously, you schedule your checkups, you review your insurance, you start thinking about future stability instead of only the present moment. Humanity is doing the same thing now, but on the scale of an entire planet. This isn't paranoia. It's maturity. It's what it looks like when a species begins to watch its neighborhood carefully, not fearfully, but responsibly. And the metaphor continues. Earth and Mars became like two quiet neighbors standing out on their porches at night, watching a stranger walk down the street. Not alarmed, not threatened, just paying attention, noting the details, learning the pattern, so the next time a visitor wanders by, they're ready. Maybe a little more practiced, maybe a little more precise, maybe a little less surprised. This idea that we can use whole planets as measurement tools would have sounded like science fiction 50 years ago. Now it's simply another chapter in the way humanity is growing up. We don't get to choose which interstellar objects pass through our neighborhood, but we can choose how well we measure them. And using Mars as a second observatory turned a rare event into a precision experiment. In a way, this was a fire drill for the entire solar system. And we passed without even waking most people up. But Mars didn't just help us track where 3I Atlas was going. It raised a quieter question. Did this visitor leave anything behind? By now, you've followed 3I Atlas from the wide emptiness beyond the planets, past its unexpected flare-ups near the Sun, and through its quiet, unplanned appearance in the skies above Mars. You've seen how the orbiters became interplanetary cameras, how the comet's many jets reshaped its path, and how Mars helped us measure it with remarkable precision. Now comes the question almost everyone quietly wonders the moment they hear about a close pass like this. Did it do anything to Mars? Did the red planet feel it? Did this visitor leave a mark? This part of the story demands honesty, calm, clear, grounded honesty. And it begins with three firm, reassuring truths. First, 3I Atlas never came close enough to collide with Mars. Second, there is no evidence of any kind of meteor shower or dust fall hitting the surface. Third, nothing in Mars's climate, atmosphere, or environment shows signs of being altered by the comet. Those are the facts, offered in the clearest possible voice. There was no danger, no contamination, no invisible storm, no dramatic impact. Mars remained Mars, calm, cold, steady, unchanged to the naked eye. And yet, the story doesn't end there. Because even when nothing dramatic happens, something still happens. Here's what we do know. MAVEN, circling high above Mars, watched the hydrogen corona of Atlas from a vantage point no other spacecraft possessed. This wide cloud of hydrogen was the product of water molecules being broken apart by sunlight, evidence that Atlas was shedding water as it moved. That water once belonged to another star system. Its atoms were born under a different sun, in a different time, shaped by a different history. Most of that hydrogen drifted through space untouched. A diffuse whisper, a faint glow in ultraviolet. There's no strong scientific evidence that a significant amount of it mixed with Mars's upper atmosphere. No reading from MAVEN or TGO or Mars Express suggests a measurable deposit. The hydrogen cloud passed by, mostly indifferent, the way wind passes by a mountain without leaving a trace. But if you'll allow me a brief thought experiment, clearly labeled for what it is, a moment of gentle imagination rather than a scientific declaration. Picture this. What if just a few molecules from 3I Atlas brushed the upper fringe of Mars's exosphere? What if a handful of atoms, nothing more than a wisp, slipped into the thin, cold air above the planet? What if one hydrogen atom, born orbiting another star, traveled millions of years before ending its journey near the red planet? Scientifically, this would be insignificant. Philosophically, it changes everything. Because if even one atom from Atlas touched Mars, then Mars is no longer a world made entirely from the materials of our own solar system. Its story would carry a footnote, quiet, almost invisible, but real. And maybe that idea resonates with you more than you expect. Because at this point in your life, you understand that most of what shapes a person doesn't arrive loudly. It doesn't break things or overturn the world. Most of the changes that really matter slip in quietly. A conversation you didn't expect, a night you remember for no clear reason, a book you read that rearranged something inside you, even if only by a fraction. Life's biggest turns rarely announce themselves. They arrive gently, like dust from a passing comet. So when you ask, did 3I Atlas change Mars forever? The answer depends on how you define change. In the strict language of science, the answer is almost certainly no. No storms, no chemical shift, no lasting imprint detectable by instruments. But in the language of history, of cosmic storytelling, the answer is absolutely, undeniably yes. From now on, every scientific timeline of Mars will include a single line that wasn't there before. October 3rd, 2025. Close pass by 3I Atlas, an interstellar visitor. Nothing dramatic, nothing destructive, but entirely unprecedented. And these small lines, these quiet entries in the journals of planets, matter deeply. They show us how wide and interconnected the universe truly is. They remind us that even a planet as old and weathered as Mars can have a chance encounter with a traveler from another sun. They remind us that we are part of a cosmic neighborhood where paths cross more often than we once believed. Because the truth is this: sometimes the biggest changes in science aren't earthquakes. They're footnotes. Sometimes the most meaningful encounters barely leave a mark on the surface, but linger in our understanding. And even if Mars didn't feel anything, we did. And if you sit with that for a moment, if you let yourself imagine a lonely hydrogen atom finally brushing a planet after millions of years, you start to sense the deeper connection. not just between Mars and Atlas, or between our solar system and another, but between every small encounter that shapes a life, a planet, or a universe. From now on, every map of Mars, every future mission log, will quietly carry the date when an object from another star brushed past it. Not as a warning, but as a reminder that the universe is threaded together by meetings so small we almost miss them. And to understand what this quiet encounter really means, we have to zoom out and look at the other visitors that have wandered through our sky. By now, you've traced the quiet encounter between Mars and 3I Atlas, felt the precision with which we measured its path, and reflected on the subtle ways it left its mark, not on Mars's landscape, but on our understanding. Now we zoom out, far out, beyond a single comet, beyond a single event, beyond even the comfort of assuming our solar system is self-contained. Because 3I Atlas is not alone. It is the third member of a growing family, a family we didn't even know existed 8 years ago. To understand what Atlas represents, you have to place it alongside the two visitors that came before it. Two objects that, in just a few short years, forced astronomy classrooms, textbooks, and late-night conversations to rewrite their definitions of what it means to belong to the solar system. The first was 1I Oumuamua in 2017. It wasn't bright. It wasn't surrounded by a coma. It didn't trail a shimmering tail. It was dark, so dark that it reflected barely any sunlight at all. And it was small, so small that telescopes struggled to see it until it was practically leaving. Its orbit, though, told a story. It wasn't bound to the sun. It had entered too fast, moved too sharply, and was leaving too decisively to be local. Oumuamua also behaved strangely. It accelerated slightly without a visible jet or tail. It changed brightness in ways that suggested an elongated shape or a tumbling motion. And the scientific community erupted with theories. Hydrogen iceberg, fractured interstellar nitrogen sheet, porous dust pancake, or, if you preferred the wilder edge, a probe, a light sail, a relic of technology from another system. No conclusion ever stuck. And so, Oumuamua became something else, a symbol of cosmic weirdness, a reminder that the universe contains objects that don't fit neatly into our models. 2 years later came 2I Borisov in 2019. It was, in almost every way, the opposite of Oumuamua: bright, active, clear coma, clear tail. A comet that behaved exactly like the kinds we grew up hearing about, except for one crucial detail. It wasn't from here. Spectra showed it carried more CO and CO2 than typical solar system comets. But overall, it looked familiar, comfortingly familiar. Borisov offered astronomers something like a baseline. Yes, interstellar comets exist, and sometimes they're not exotic at all. Then, in 2025, came 3I Atlas, and this object didn't sit cleanly on either end of the spectrum. Instead, Atlas slid into place as a kind of bridge. Atlas had a coma. It had multiple tails. It had the glow and the activity you'd expect from a comet. In that sense, it was closer to Borisov, a comet from afar that still felt like a comet. But the details, the multi-jet behavior, the unexpected asymmetry, the stronger than predicted non-gravitational forces, the restless patterns, it all pointed back toward the strangeness of Oumuamua. Not identical, not shocking, but definitely outside the clean, quiet curves that define textbook comets. So Atlas became something new, a connector, a missing middle piece. proof that interstellar visitors are not a single category, but a spectrum. A reminder that nature rarely follows our tidy labels. And here's where the story widens. Each interstellar object we've seen is not just a visitor, it is a sample, a tiny physical fragment of a star system we will never travel to, formed under conditions we cannot recreate, shaped by histories we cannot witness. Oumuamua may have come from a place where collisions were so violent that only thin, stretched fragments survived. Borisov likely formed in a system with abundant volatile ices, cold, quiet, and stable enough to preserve them. Atlas, with its large size and vigorous jets, might hail from a system where comets grow bigger, older, more active. Each visitor is its own postcard from a distant sun. Each one adds a line to the map of how planets and comets form across the galaxy. Together, they imply something humbling and beautiful. Our solar system is not the template. It is just one expression among billions. There are countless ways for worlds to be made, shattered, rebuilt, and launched into the dark. What we see here, our own pattern, is only one flavor in a cosmic spectrum. And for you, listening now, there is something extraordinary in that realization. You're living at the first moment in human history when we aren't guessing about the materials of other stars. We're seeing them, watching them drift through our backyard, listening to them whisper their stories in the faint glow of their coma. Your grandparents never had this. Your parents didn't either. Even you, 20 years ago, couldn't have imagined opening a video like this and hearing about the third interstellar visitor passing through a neighboring planet's sky. In just 8 years, we went from never seeing an interstellar visitor to arguing over 3 of them. Each arrival shook something loose. Each one widened the horizon. Each one made the galaxy feel just a little more connected to our everyday lives. And of course, with every new visitor, something else wakes up. The human imagination. When Oumuamua arrived, people wondered, was it a craft, a beacon, a sail? When Borisov arrived, people asked, if this one looks normal, does that make the first one look even stranger? And now, with Atlas, internet forums light up again. Jet patterns too weird? Orbit too active? Hydrogen cloud too big? What if? It's natural. Humans look for meaning. We tell stories. When something arrives from another star, our telescopes turn on, and so do our wildest ideas. But Atlas offers a softer kind of wonder. Not panic, not conspiracy, just the beauty of knowing that nature is plenty strange on its own, that we don't need alien machines to feel awe, that the universe, left to its own laws, is already far weirder than fiction. And whenever something from another star shows up in our sky, our telescopes turn on. And so do our wildest stories. Whenever something wanders into our solar system from another star, something else always wanders into the conversation. The idea that maybe, just maybe, it wasn't entirely natural, every time. It happened in 2017 with Oumuamua. It happened in 2019 with Borisov. And it's happening again now with 3i Atlas. The moment the news breaks, the internet fills with titles like Alien Probe, Signals Detected, Lights Over Mars. You can almost set your watch by it. And honestly, this reaction says more about us than it does about the objects themselves. Humans are wired to react this way. When we encounter something rare, fast-moving, poorly understood, and not from around here, the imagination kicks in. It's an ancient instinct. Before we had telescopes, before we had spacecraft, before we even knew what stars were, anything unusual in the sky felt like a message, a sign, a visitor, something with intention. So when 3I Atlas entered the scene, the theories bloomed overnight. People zoomed into noisy pixels, convinced they'd found panels or engines. Others speculated that the unusual jets and shifting brightness were artificial maneuvers. And a few declared that the timing of its Mars flyby was too perfect to be accidental. If you spend a few minutes online, you can find every flavor of speculation, some playful, some dramatic, some absolutely wild. Part of the fuel for this comes from one of the most famous voices in the field, Dr. Avi Loeb, who famously made a public bet for $1,000 that humanity will find evidence of intelligent life by 2030. Not because he claims every odd object is a spacecraft, but because he argues we shouldn't ignore bold hypotheses. Loeb never said Atlas was artificial, but he does encourage the scientific community to stay open-minded. It's the same spirit that Carl Sagan captured with his iconic reminder, extraordinary claims require extraordinary evidence. And when you apply that standard to Atlas, the picture becomes much clearer. Everything we've seen so far is entirely consistent with a natural comet. No signals, no controlled acceleration, no plasma behaving like an engine plume, no geometric symmetry that screams manufactured. Every unusual feature, the twisting jets, the multi-tail pattern, the restless brightness, the non-gravitational nudges, can be fully explained by natural processes. When a comet spins, warms unevenly, cracks, vents, precesses, and tumbles, it can look chaotic. And Atlas, traveling for millions of years between stars, carries the scars and quirks of that long journey. So why do the alien ideas land so quickly? Because we're meaning-making creatures. Our brains prefer intention over randomness. A mysterious object feels more satisfying when there's a storyteller behind it, especially for people in their 40s and beyond. People who have lived long enough to crave purpose, to ask big questions, to hope there's something more out there than work email, traffic lights, routines, and the slow passing of days. The idea of a visitor, a message, a sign, taps into something deep. Not childish wonder, but grown-up longing. And yet, here's the gentle truth. 3I Atlas doesn't need aliens to be fascinating. It's already strange, already unpredictable, already older than any civilization that has ever walked the earth. It behaves the way it does not because it's engineered, but because nature itself, especially across star systems, is far more complex than we expect. The universe doesn't owe us clean patterns. Chaos is part of the design, and beauty is often hidden in the irregularities, not the simplicities. Think of a cold winter morning. You step outside, and the air feels sharp. The wind moves without permission. The sky has no message for you, but you still feel something. Not because someone crafted the moment, but because nature has a quiet power of its own. Atlas is like that. Beautiful, not because someone built it, but because no one did. And here's an adult truth that settles softly. The universe is weird enough without conspiracies, wild enough without spacecraft, mysterious enough without a single alien hand touching anything. Even in its purely natural form, Atlas carries matter older than our sun, forged in a system we may never see, shaped by physics we barely understand. That alone is extraordinary. That alone is worth wonder. But maybe the deepest question is this: why do we want aliens so badly in the first place? Maybe because, in a universe this vast and this quiet, we want to feel accompanied. We want the story to include someone else, someone watching, someone thinking, someone wondering back at us. There's comfort in that idea. Not fear, comfort. But the comfort doesn't have to come from aliens. Sometimes it comes from realizing that nature itself already looks alien. The truth isn't disappointing. It's dazzling. We're not disappointed that it isn't aliens. We're amazed that nature itself can look this alien. And beyond the wild stories, there's something far more grounded and far more important that this comet reminded us of. If you're listening to this right now, chances are you're lying in a quiet room somewhere in the United States, sometime after a long day that asked more of you than you wanted it to. Maybe there's a soft lamp on the nightstand, casting a warm shape across the wall. Maybe the rest of the house is asleep. Maybe the only sound is the faint hum of the air vent or the distant traffic settling into silence. And it's just you now, you and the soft glow of your screen, letting the universe unwind your thoughts for a while. You've moved through deadlines today, through emails that asked for one more thing, through responsibilities that stacked up quietly, the way they tend to at this stage of life. You've solved problems no one saw, carried pressures no one thanked you for, put things in order so tomorrow isn't harder than it needs to be. And now, while you lie here in stillness, something else entirely is happening far beyond your window. Out there, 3i Atlas is moving at more than 150,000 miles per hour, gliding through the dark with a momentum older than Earth. It has crossed the orbit of Mars, past its moment of closest approach to the Sun, and is now drifting outward again, carrying traces of a star that isn't ours. It doesn't know you're listening. It doesn't know you're tired. It doesn't know what your day felt like. And somehow, that makes this moment feel gentler. Because while you were answering emails, Atlas was streaking across space. While you were stuck in traffic, Mars was quietly watching it. While you were trying to stay ahead of your responsibilities, an entire world, silent, frozen, dusted in red, caught a glimpse of something that most of humanity didn't even look up to see. And that's where the connection begins. Not in the details of the comet, but in the feeling. You and Mars have something in common. Mars has survived global dust storms that swallowed the sky for months at a time. You've survived seasons in your own life that felt just as blinding, even if no one else noticed. Mars has been shaped by impacts, real, violent, ancient, and it kept going anyway. You've taken hits too. Setbacks, disappointments, things that changed you in ways you didn't choose. Mars keeps turning. So do you. It's a strange comfort. A cold, distant planet and a man lying in a warm room have more in common than you'd think. You're both still here. You're both still turning. You're both still doing your work, even when no one sees the effort. And here's a truth simple enough to hold in your hands. You don't control the universe, but you control the next breath you take. The universe is enormous, wide enough to swallow whole galaxies, patient enough to watch stars burn out, quiet enough to make your loudest worries seem small. Nothing that happened to you today was too big for a universe this wide. Nothing was permanent. Nothing was final. Everything you carried today was part of a larger pattern, a pattern that stretches far past the edges of stress, past the deadlines, past the noise. That's the gift of a cosmic zoom out. It shrinks the things that frightened you. It softens the sharp edges of your thoughts. It reminds you that life, even on its heaviest days, is still part of something vast and deeply connected. And now, think of Atlas again, the comet that caused so much curiosity, so much analysis, so many measurements. It's already past its brightest moment. It has completed its swing around the sun. It's heading out of the solar system slowly, on a path that will eventually take it back into the deep interstellar night. It will spend years, then centuries, then millennia moving farther away, until it becomes just another faint traveler between the stars. It continues, and you continue. Different journeys, but under the same quiet sky. Wherever you are listening, the roof above your head, the thin layer of atmosphere above that, and the darkness beyond are all part of the same place. You don't need to be on Mars or floating above Earth to be connected to the story. You're already in it. You're part of the neighborhood Atlas just passed through. You're part of the timeline that recorded its visit. You're here, alive, awake, even if barely, in the exact moment of human history when these encounters are no longer science fiction, but quiet, measurable reality. You're part of this story, even from your quiet room. So take a slow breath. Let your shoulders soften. Let your thoughts stretch out into the dark, where everything moves at its own calm pace. Atlas is moving. Mars is quiet. And so are you. And as we look ahead, there's one date circled quietly on every astronomer's calendar. As you lie there under your quiet ceiling, the story shifts one more time, gently, naturally, from what Atlas has already shown us to what it might show us next. Because even though so much has happened, the comet's journey isn't finished yet. In fact, one of its most important moments is still ahead. December 19th, 2025. A date circled quietly on the calendars of astronomers all over the world. Not because of danger, not because of drama, but because on that night, 3I Atlas will make its closest approach to Earth. Still far, still harmless, still beautifully distant at around 270 million kilometers. That's almost twice as far as the Sun. But in cosmic terms, this is a close pass, a moment when the angle of sunlight, the geometry of its path, and the position of our observatories line up just right. And every major observatory is getting ready. JWST has queued observations that will peer deep into the comet's spectrum, looking for organic signatures, unusual ices, and the chemical fingerprints of whatever ancient star system forged this object. Subaru and VLT will take high-resolution images of the jets, trying to map their angles as they change. ALMA will listen for faint radio signatures from dust grains as they cool after perihelion. Together, these telescopes will build the December chapter of the Atlas story, a chapter that hasn't been written yet. What are scientists most curious about? Plenty. They want to know the comet's composition now that it has swung around the sun and lost some of its outer layers. They want to see whether the jets quiet down or flare up again. They want to measure how the nucleus responded to the heat of late October. Did it fracture? Did it stay intact? And they want to track the shrinking hydrogen corona, mapping the last traces of evaporating water before the comet sinks into colder regions where everything begins to freeze again. Astronomers describe interstellar visitors as stories in motion, not static objects, not simple facts, but unfolding events, changing day by day, reacting to sunlight, to rotation, to chemistry, to time. And that's why this video, this very moment you're listening in early December, is a perfect snapshot. 1 month of fresh data behind us. 1 month of fresh data ahead. You're catching Atlas in the middle act, right when the story is clearest, before it slows and dims and fades. There's something comforting in that, because you don't need every answer tonight. You don't need to know the final composition, the final orbit, the final images. You just need to know the direction. You need to know what's coming next. And it's okay that the details are still unwritten. That's true for you too. Whether it's your job, your worries, your plans, or the next chapter of your own life, clarity doesn't always come all at once. Sometimes it comes in stages, like telescope images slowly stacking into something recognizable. Picture Atlas now, a faint, ancient traveler passing through the solar system as if it were walking past a street lamp at night. We stand on Earth, looking out through our little window, catching a glimpse as it crosses our patch of sky. And soon, it will continue on, back into the dark, back into the long road between the stars. It won't return, not in a million years, maybe not ever. But that's the beauty of a moment like this. Its value isn't in permanence, it's in presence. You were here to see it. You were alive in the small century when we witnessed 3 interstellar objects drift past our sun. You're a witness to something no generation before you could have imagined. We are living through only the 3rd time in human history that something from another star swings past our sky. That alone is extraordinary. And as Atlas continues outward, the science will keep unfolding. We'll track it through mid-December. We'll watch it dim. We'll watch the jets weaken. We'll watch the hydrogen cloud thin. And eventually, the comet will become too faint for even the best telescopes, slipping into the silence where only gravity guides it. But not yet. Not tonight. Tonight, its story is still moving, and you're still part of it. So we'll meet Atlas again in mid-December. And when we do, it may be quieter, colder, and further away. But still beautiful. Still worth following. Still leaving a small, meaningful line in the history of our solar system. Every interstellar object is a postcard from another sun. And 3i Atlas is the one arriving in your lifetime, addressed to anyone willing to pause long enough to look. We're watching cosmic history in real time. So before we let Atlas fade into the dark, let's take one last quiet look at where we stand tonight. And now, as your breathing slows and the weight of the day begins to release its hold, the story settles into its final chapter. The part where the universe quiets down again. The part where the visitor keeps going, and you stay here, safe, warm, and ready for rest. Out there, far beyond your window, 3i Atlas is fading in the eyepieces of the telescopes that spent months following it. The comet's long tail, more than 150,000 kilometers of dust and gas, is thinning, dissolving into the darkness like a trail of smoke in the night air. What was once bright and restless now softens into a dim streak, moving steadily away from the sun. Even Mars, which held such a perfect vantage point weeks ago, has rotated into a new season. turning its cold deserts toward a different slice of sky. The red planet no longer sees Atlas. It has slipped out of view, and everything is calm. Earth is calm. Mars is calm. The visitor is leaving quietly, carrying nothing with it except the data we gathered, the images we stitched together, and the sense of wonder it left behind. The observatories are closing this chapter too. NASA's servers have archived their final exposures. ESA's instruments have gone back to their routine tasks. No more bright jets to measure. No more hydrogen clouds to map. No more shifting orbit to refine. Just a small dot drifting outward, losing brightness with every passing day. If you listen closely, not with your ears, but with that quiet part of your mind that holds on to meaning, you can almost imagine a cosmic closing ceremony. Screens dimming, graphs going silent, the hum of instruments easing into their background rhythm. Astronomers leaning back in their chairs, knowing one more visitor has passed and left safely. And now, the night belongs to you again. You followed the whole journey. You followed a traveler from another star, from Discovery to Mars to perihelion to the calm path outward again. You stayed with the story through curiosity and data, through wonder and reflection, and now you're here, at the end of it, with nothing required of you except rest. Let that sink in for a moment. You don't have to solve your life tonight. You don't have to fix every worry or plan every tomorrow. The universe isn't asking anything from you. You're allowed to stop. You're allowed to soften. You're allowed to rest. The whole cosmos is wide, ancient, and impossibly patient. You don't have to match its pace. You don't have to carry its weight. Right now, all you need is the next breath. So inhale gently, like the universe expanding, and exhale slowly, like a comet drifting into the dark. Again, inhale and exhale. Let the rhythm settle into your chest, the way orbits settle into their path. Atlas is moving away now. Its light is dimming. Its story is quiet, and nothing in it demands anything of you. You're safe. Your world is steady. The visitor is gone, and the sky is yours again. Somewhere in the future, months, years, or decades from now, another traveler will wander in from a distant star. Another story will begin. Another quiet chapter will unfold. And when it does, we'll be here to tell it. But not tonight. Tonight is for rest. Tonight is for letting the universe hold the big questions while you drift. In the end, every comet is just passing through, just like us. So close your eyes. Let your thoughts fall quiet. Let your breathing carry you the rest of the way. Good night, traveler. The universe is quiet tonight.